talk about matrices and see what A times B has in common with B times A. If you know about multiplying matrices together, you know it's not necessarily the case that multiplication is commutative. These two products might be completely different. And I mean completely different. They might even have different sizes. Like even if the two matrices you start with have the same size, their products are going to have the same size, I guess, but the entries aren't going to be equal to each other. But there actually is something that AB has in common with BA, and I wonder if you see it on the screen. It's the fact that no matter which way you multiply the matrices, the sum of the diagonal entries has to be the same. In this case, it's the number 2, and down here, it's going to be the number -3. It even works in this crazy example, it's going to be 9. The sum of the diagonal entries of a matrix is called the trace of that matrix, and I've just shown some examples illustrating this cool fact that the trace of AB is the same as the trace of BA. To really see why it's true, you have to kind of get into the details of matrix multiplication and work out exactly what goes to the diagonal, but I'm going to show you some examples that basically give the idea. This is a great thing to do in math when you're not sure why something is true, is to try and do some general examples. For instance, here I have two 2x2 matrices, and when I multiply them together, I don't get the same entries on the diagonal, but I notice that there's some overlap of terms. For instance, if I add the 4 terms here, and I add the 4 terms here, at the end, I get the same 4 things. It's also a good idea to try and do slightly more general examples. For instance, here the matrices have different sizes, and you can see that we get very different answers. Here's a 3x3 matrix, and here's a 2x2 matrix. But when you zoom in and you look at the diagonal entries, you see that when we add them together, we get the same thing in both cases. Trace of a matrix is actually a pretty important invariant because it's preserved upon change of basis. And actually it follows by what we just proved. And it's also true that the trace of a matrix is exactly the sum of the eigenvalues taken with multiplicity. Lots of cool stuff going on.